Fiber optic technology and Ethernet technology are two major players in the world of data transmission. Both technologies play an important role in transmitting data and communicating information. The purpose of this article is to provide a comprehensive overview of both fiber optic and Ethernet technologies and to compare their differences, advantages, and when to use each of them. Key points to be covered in this article are the definition, components, key features, and benefits of both technologies, as well as the steps and advantages of converting fiber optic to Ethernet. We will also look at which one is better overall. What is fiber optic technology? Fiber optic technology is a method of transmitting information from one point to another using light signals that are transmitted along thin, flexible fibers made of glass or plastic. It has become an essential component of our daily lives, providing fast and reliable communication over long distances. These fibers are transparent and have a very small diameter, typically around a few thousandths of an inch. They are capable of transmitting data over long distances at extremely high speeds and with minimal signal loss, making them an ideal choice for many applications, including telecommunication, data transfer, and internet connectivity. The light signals used in fiber optic technology are generated by a light-emitting diode, LED, or a laser diode. The light signals are then transmitted through the fibers, which act as a waveguide, carrying the light from one end of the cable to the other. The light signals are received by a photodetector, which converts the light signals back into electrical signals that can be processed by electronic devices. One of the main advantages of fiber optic technology is its high bandwidth capacity. This means that large amounts of data can be transmitted simultaneously over long distances without any loss of quality or speed. This makes fiber optic technology ideal for applications that require high-speed data transfer, such as video conferencing, cloud computing, and streaming media. Another advantage of fiber optic technology is its immunity to electromagnetic interference, EMI. Unlike copper cables, which can be affected by EMI, fiber optic cables are immune to interference from electrical and magnetic fields. This makes them ideal for use in environments where EMI is a concern, such as in medical facilities, industrial plants, and near power lines. Fiber optic technology has also been instrumental in the development of the Internet. The high bandwidth capacity and low signal loss of fiber optic cables make them ideal for long-distance Internet connectivity, allowing data to be transmitted across continents in just a few milliseconds. Fiber optic technology is a critical component of modern communication and information transfer. Its high bandwidth capacity, immunity to EMI, and ability to transmit data over long distances make it an ideal choice for a wide range of applications. As technology continues to advance, fiber optic technology is expected to play an even more significant role in the future of communication and information transfer. What is Ethernet technology? Ethernet technology is a method of connecting computers and other devices to form a local area network, LAN. It is a standard that governs the physical and data link layers of the OSI, Open Systems Interconnection, model, the standard reference model for data communication protocols. Ethernet provides a reliable and efficient means of transmitting data between computers and other network devices. Ethernet was first introduced in 1980 by Xerox Corporation and has since become the dominant LAN technology, with over 90% of LANs worldwide using Ethernet. Ethernet operates on the principle of packet switching, which involves breaking data into small packets, transmitting them individually, and reassembling them at the destination. There are several different variants of Ethernet, each with different speeds and capabilities. The most common variants are Ethernet 10 base T, 10 Mbps over unshielded twisted pair, UTP, cable. Ethernet 100 base TX, 100 Mbps over UTP cable. Ethernet 1000 base T, 1 Gbps over UTP cable. Ethernet 10G base T, 10 Gbps over UTP cable. Ethernet technology is also used in other types of networks, such as metropolitan area networks, MANs, and wide area networks, WANs. Ethernet can be used over a variety of physical media, including UTP cable, fiber optic cable, and coaxial cable. One of the key advantages of Ethernet is its simplicity. Ethernet is easy to install and maintain, and it is compatible with a wide range of devices and operating systems. Another advantage of Ethernet is its scalability. Ethernet networks can be easily expanded as the number of devices on the network grows, and they can be upgraded to faster speeds as technology advances. Ethernet technology is a widely used, reliable, and efficient method of connecting computers and other devices to form a LAN. It provides a flexible and scalable solution for data communication and is the dominant LAN technology in use today. Whether you are setting up a home network or a large enterprise network, Ethernet is a technology that you should consider. Differences between Ethernet and fiber optics. The key differences between fiber optic and Ethernet technology include speed comparison, distance limitations, data transmission characteristics, and cost comparison. Fiber optic technology is faster than Ethernet technology and provides higher bandwidth and lower latency. Ethernet technology is limited in terms of distance, whereas fiber optic technology can transmit data over long distances with minimal signal loss. In terms of data transmission characteristics, fiber optic technology is more reliable and secure, whereas Ethernet technology is more cost-effective. When to use fiber optic technology? Fiber optic technology is best suited for applications that require high speed, long-distance transmission, reliability, and security. These applications may include data centers, internet service providers, financial institutions, and government organizations. Fiber optic technology has become an indispensable part of modern communication and networking systems. But the question remains, when is the best time to use it? Here are 4 ways that may make fiber optics the technology of choice. High-speed data transfer. Fiber optics are capable of transmitting data at extremely high speeds, making it ideal for situations where high bandwidth is required. For example, in data centers, high-speed data transfer is crucial for seamless operation and fiber optics provides the necessary bandwidth to achieve this. Long-distance communication. Fiber optics are ideal for long-distance communication, where signals need to be transmitted over distances greater than 100 meters. For example, it is commonly used for long-distance telecommunications, such as internet service providers connecting cities, and for interconnecting data centers located far from each other. No electromagnetic interference. Unlike copper cables, fiber optics are immune to electromagnetic interference, EMI, making them ideal for applications in environments where EMI is a concern. For example, in medical environments, fiber optics can be used to transmit data without interfering with medical equipment. Safety. Fiber optics are not electrically conductive, making them safer to use in environments where electrical safety is a concern. For example, fiber optics can be used to transmit data in hazardous environments, such as oil rigs, without posing a risk of electrical shock. When to use Ethernet technology? Ethernet technology is best suited for applications that require short-distance transmission, and budget constraints, and are simple and easy to use. These applications may include home networks, small businesses, schools, and hospitals. Converting fiber optic to Ethernet involves the use of equipment and tools, such as optical media converters, fiber optic transceivers, and Ethernet switches. The steps to convert fiber optic to Ethernet include selecting the appropriate optical media converter, connecting the fiber optic cable to the optical media converter, connecting the Ethernet cable to the optical media converter, and configuring the Ethernet switch. The advantages of converting fiber optics to Ethernet include cost savings, compatibility with existing Ethernet devices, and easier maintenance and management of existing Ethernet systems. Is fiber technology better than Ethernet? The short answer is yes, in terms of performance. But in real-world contexts, the answer is more likely to be maybe. When it comes to specifications, fiber wins almost every time. Whether or not to use Ethernet instead will be determined by two important factors: budget and project requirements. Fiber optic cables are currently a little ahead of their time. Fiber can be considered overkill for facilities such as small companies and households. Fiber, on the other hand, will eventually become the industry standard. Ethernet will most likely be phased down over time, but it will happen. Data usage has risen significantly in recent years, and this trend is expected to continue as technology advances. Ethernet will eventually reach a limit, whereas fiber will be able to continue to advance. Installing a fiber optic infrastructure now can eliminate the need for a comprehensive network redesign later. With the unrelenting growth in bandwidth demands, fiber optic cabling offers undisputed advantages over traditional copper Ethernet cable. Optical fiber transmits data as light pulses over long distances with virtually unlimited capacity. Fiber supports extreme speeds up to 100 Gbps and beyond. In contrast, copper Ethernet tops out at 10 Gbps for short stretches before signal degradation. Fiber also remains immune to electromagnetic interference that can plague metallic cables. Additionally, fiber's small size and weight enable higher cable densities and lighter weight installations. Thanks to these superior characteristics, fiber optic cabling provides the essential high-speed backbone to support emerging bandwidth-hungry applications from 5G to hyperscale cloud computing. While copper retains a role for short in-building links, fiber optic cabling clearly dominates as the preferred choice for high-performance network backbones and data center interconnects. Both fiber optic and Ethernet technologies have their own strengths and weaknesses, and the choice between them will depend on the specific needs of your application. Whether you choose fiber optics or Ethernet, it is important to work with a trusted and experienced company to ensure the best possible solution. Fiber optic cables and LAN, local area network, cables are two different types of transmission media used for networking. Fiber optics are often chosen for high-performance, long-distance applications, while LAN cables are commonly used for shorter distance connections in local networks. What is an optical fiber cable? An optical fiber cable, commonly known as a fiber optic cable, is a type of cable that contains one or more optical fibers, thin strands of glass or plastic that can transmit data in the form of light pulses. These cables are used for high-speed data transmission over long distances and are a key component in telecommunications networks, internet infrastructure, and various other applications. Here are the main components and features of an optical fiber cable. 1. Optical fibers. Material: the fibers are typically made of glass or plastic. Glass fibers are more common in high-performance applications due to their lower signal loss. Core and cladding: an optical fiber consists of a core, the inner part, and a cladding, the outer part. The core is where the light signals travel, and the cladding is designed to keep the light within the core by reflecting it. This structure enables the principle of total internal reflection for efficient signal transmission. 2. Buffer coating. Protective layer: each optical fiber is surrounded by a buffer coating, which serves as a protective layer. This coating helps prevent damage to the delicate fibers during handling, installation, and use. 3. Strength members. Reinforcement: fiber optic cables often include strength members, such as aramid yarn or fiberglass, to provide tensile strength and protect the fibers from stretching or breaking. 4. Outer jacket. Protective cover: the entire cable is encased in an outer jacket, which provides additional protection against environmental factors like moisture, chemicals, and physical damage. 5. Types of fiber optic cables. Single-mode fiber, SMF, designed for long-distance transmissions. Single-mode fibers allow only one mode, path, of light to propagate through the core. These are common in telecommunication networks. Multi-mode fiber, MMF, suited for shorter distance transmissions. Multi-mode fibers allow multiple modes of light to propagate through the core simultaneously. They are often used in LANs and data centers. 6. Applications. Telecommunications: fiber optic cables form the backbone of modern telecommunications networks. facilitating high-speed data transmission for telephone, internet, and television services. Data centers, fiber optics are used to connect servers, storage, and networking equipment within data centers, enabling high bandwidth and low latency communication. Internet backbone, the global internet infrastructure relies heavily on fiber optic cables for intercontinental and transoceanic data transmission. 7 advantages. High bandwidth, fiber optic cables offer high bandwidth, enabling the transmission of large amounts of data at high speeds. Low signal loss, optical fibers experience minimal signal loss over long distances, allowing for efficient data transmission. Immunity to electromagnetic interference, unlike copper cables, fiber optics are not susceptible to electromagnetic interference. What is an LAN cable? A LAN cable, or local area network cable, is a type of cable commonly used to connect devices within a local network. LAN cables are a fundamental component of wired networking and are widely used in homes, offices, and various other environments where devices need to communicate over a short distance. Here are the key features and components of a LAN cable. 1. Conductor material. LAN cables typically use copper conductors for data transmission. Copper provides good conductivity and is cost-effective. 2. Twisted pair configuration. Most LAN cables consist of twisted pairs of copper wires. The twisting helps to reduce electromagnetic interference, EMI, and cross-talk between adjacent pairs. 3 categories of LAN cables. LAN cables are categorized based on their performance characteristics. Common categories include Cat5e, Category 5e, Cat6, Category 6, Cat6a, Category 6a, and Cat7, Category 7. Each category has specific specifications for data transmission speed and bandwidth. 4 RJ45 connectors. LAN cables terminate with RJ45 connectors at each end. These connectors have 8 pins and are designed to be compatible with Ethernet ports on computers, routers, switches, and other network devices. 5 applications. LAN cables are used to establish wired connections between devices in a local network. Common applications include connecting computers, printers, routers, switches, and other networking equipment within homes, offices, and data centers. 6. Data transmission speed. The data transmission speed of a LAN cable depends on its category. For example, Cat5e cables can support speeds up to 1 gigabit per second, Gbps, while Cat6 and Cat6a cables can support higher speeds, such as 10 Gbps. 7. Distance limitations. LAN cables are generally designed for relatively short distance communication within a local area network. The effective distance can vary based on the cable category and the desired data transmission speed. 8. Flexibility and jacketing. LAN cables come in various designs to suit different installation needs. They may have different levels of flexibility, and the outer jacket of the cable provides protection against environmental factors. 9. Power over Ethernet, PoE. Some LAN cables, especially those of higher categories like Cat6 and Cat6a, support power over Ethernet, PoE. PoE allows electrical power to be transmitted along with data over the same cable, which is useful for powering devices like IP cameras and VoIP phones. The difference between fiber optic cable and LAN cable. The choice between fiber optic cables and LAN cables depends on factors like transmission speed, distance, susceptibility to interference, and the specific requirements of the networking application. Here are the key differences between fiber optic cables and LAN cables. 1. Transmission medium. Fiber optic cable utilizes optical fibers made of glass or plastic for transmitting data. Light signals are used to carry information through the cable. LAN cable, typically copper, uses metallic conductors, commonly copper, to transmit electrical signals. 2. Transmission speed. Fiber optic cable offers higher transmission speeds, typically in the range of gigabits per second, Gbps, to terabits per second, Tbps. LAN cable, supports lower transmission speeds compared to fiber optic cables, usually ranging from megabits per second, Mbps, to gigabits per second, Gbps. 3. Transmission distance. Fiber optic cable provides longer transmission distances without significant signal loss, often spanning tens or hundreds of kilometers. LAN cable generally has shorter transmission distances, typically in the range of tens to hundreds of meters. 4. Resistance to interference. Fiber optic cable, highly resistant to electromagnetic interference and radio frequency interference. It is not affected by electrical noise. LAN cable, susceptible to electromagnetic interference and may experience signal degradation in the presence of external interference. 5. Physical characteristics. Fiber optic cable, lighter, thinner, and more flexible compared to LAN cables. It is also immune to issues like crosstalk. LAN cable, heavier, thicker, and less flexible than fiber optic cables. It may be more prone to issues like crosstalk, especially in densely cabled environments. 6. Security. Fiber optic cable offers higher security as it is more difficult to tap into or intercept signals due to the use of light for data transmission. LAN cable, potentially more susceptible to eavesdropping or signal interception since signals are transmitted as electrical pulses. 7. Use cases. Fiber optic cable, commonly used for long-distance, high-speed data transmission in backbone networks, data centers, and telecommunications infrastructure. LAN cable, typically used for connecting devices within a local area network, such as computers, printers, and routers in homes, offices, or small businesses. Thank you for watching this video.